Okay, let me just tell you the
Okay.
statement first, and then after we'll try to apply this Rolle's theorem to some of the questions, and we'll try to understand what is the meaning of these kind of theorems.
Okay.
Okay, first look at the statement first. What is the important ingredient for the statement? The important ingredients are there is a continuous function. Okay, there is a continuous
Yeah.
function without any break.
Mm-hmm.
Simply, this continuous function is defined over the closed interval AB,
Mm-hmm.
and the function is differentiable over the open interval AB. So important statement this time. Whenever I wish to define the continuity of the function, it should be most of the time on the closed interval
Yeah.
for most of the applications. And whenever I say that the derivative exists, it should be on the open interval. Okay, because for the
Okay.
derivative, you need the left and the right hand derivative. So for that purpose, it should be on the open interval.
Okay.
The third assumption is the value of FA and FB are equal. In this
Mm.
case, if these three conditions are satisfied, then there is at least one number, important observation, at least one number C in between AB where the derivative is zero. This is what the Rolle's theorem says. What is the meaning of this statement? Let me just tell you. Try to help me in drawing a graph.
Okay.
The function is defined from A to B.
Mm-hmm.
Okay. At A, just suppose this is the height. The value of the function at A may be considered as L. Let me consider this as L there. So I'm representing it by L. So I'm starting from this point and I have to end up to this point. The graph may be like this.
Mm-hmm.
It is smooth there, and just an assumption, it is a smooth curve, even though it doesn't look like at some point, but yes, consider it is a smooth curve.
Okay.
Okay, it is differentiable everywhere over the open interval continuity because there is no break, everything is fit and fine, and you can see that the value of F and FB are going to be same.
Yeah.
Then consider a point where you can find a tangent like this. Certainly there will be a point.
Yeah.
Okay, and let me consider C1, and let me just try to have another line, horizontal line. This is C2. So what you
Mm-hmm.
can see that the tangent line at C1 and C2 is going to be parallel to the x-axis. So if you ask me what is the derivative at C1 is going to be 0, and what is the derivative at C2, it is going to be 0 also. Am I
Yeah.
right?
Mm-hmm.
So what is the last statement says that there is at least one point C1 C in between A and B where the tangent derivative is going to be 0. Any doubts there?
Okay.
And this is going to be very useful statement whenever you are trying to find out relative maxima and relative minima.
Yeah.
See, I cannot say overall what may be the maximum, but yes, I can say that the local maximum will be at C1 and the local minimum will be at C2. Okay,
Right.
so these are the points. So the graph given to you in the book, let me just paste that graph. It is trying to tell you the similar kind of a statement what I told you. Just have a look. It is going to have a relative maxima there. Any doubt?
Nope. Wait, actually, if it's a straight line,
It's a
um,
horizontal line basically.
yeah. Oh, okay.
Okay.
Yeah.
One more observation. Just look at the statement, and if you can tell me, can we apply Rolle's theorem for this graph?
No,
The answer is no. Perfectly okay. You are right up to this point. But why? Why we cannot apply Rolle's theorem here?
because it has a cusp where
Perfectly
the
okay.
thing
Derivative does not
changes.
exist.
Yeah.
Okay, when the derivative does not exist, you are right. So the relative maximum minima may exist, even the function may not be differentiable. Okay, so
Yeah.
we have some simple tasks to perform here. It is not a big task for you. Let me start with example number 2. Example number 1 is too easy for you, so I'm not interested there.
Mm-hmm.
Uh, Illustrating Rolle's theorem, and there is a function given to x power 4 minus 2x square find all values of C in the interval -2 to 2. They have specified the interval such that the derivative is going to be 0. So
Right.
always remember, this is given to a polynomial. Polynomial are such a nice functions. They are continuous everywhere. They're differentiable everywhere. So if you allow me, because it is a polynomial, I can say that it is continuous. CTS stands for continuous on the interval -2 to 2 without any issue.
Right.
Secondly, if I tell you that derivative exists, it's an easy term for you. It is going to be 4x cube minus 4x. You can take something common if it is there.
Yeah.
Am I right? And because it is still a polynomial, it is going to be this is going to exist over the interval -2 to 2 without any issue. Why? Because I'm working on this interval only.
Yeah.
Third statement, in order to check the derivative condition, I need to check what is the value at -2. And look, the function is even function. Am I right?
Yeah.
And uh, can you please help me with the values of f2 and f -2? I think they are going to
Yeah.
be same
So yes, and yeah.
without any issue. Okay, no need to calculate
So
the
it'd be
values, but they are going to be same.
16. Oh, okay.
Okay, they are going to be same without the calculations, not required. So therefore, all the conditions of the Rolle's theorem are satisfied. So
Yeah.
therefore, by Rolle's theorem, there exists at least one important. Like I have given an example, there exists more than 1 point, at least 1 point.
Right.
Small c in belonging to the interval -2 to
So
2, such
yeah.
that the derivative at c is going to be 0. So the derivative expression you already have. Let me just write down. It is 4c square minus 1. What I did, I replaced x by c in order to calculate solve for c.
Yeah.
Simplify, c is going to be 0, yes or no?
Yeah, it could be 0,
And
1,
plus
or
minus 1.
-1.
So how many
Yeah.
points you get? You get
3.
3 points. So basically, at least one, but how many may be the maximum? We do not know. It is depending upon the question.
Yeah.
Okay, let me just show you the graph of the question related to the question. So I hope you can see that at -1, the tangent is going to be horizontal, horizontal, horizontal. Remember, you will be having maximum minima, or you may had maximum minima. I do not know till now. Have you finished maximum minima?
What?
Have you finished maxima minima topics?
Yeah.
Okay, so in maximum minima, whenever the function is differentiable, in order to get the points, the critical point and the stationary point, whatever you can use the words for the timing, the tangent is going to be parallel to the x-axis. Am I right?
Yeah.
Those are the point where the function may have a maxima minima in case of differential function. So we are just following the same rule, nothing else. Any doubt?
Nope.
Perfectly okay. Next, there is a variant. There is a new theorem called the mean value theorem, and Rolle's theorem is a special case of mean value theorem. Let me just paste the theorem first, and I'll tell you about the theorem then. Okay. So the mean value theorem, f prime c equals f b minus fa over b minus a. Let me just tell you what are the rules and how we are going to discuss this. Just suppose there is a function f which is given to you like continuous on the closed interval ab. It is like the similar or the same exactly same statement we had in Rolle's theorem. Second, assume that the derivative exists on the
Okay.
open interval ab. This is also the same statement without any issue. Am I right?
Yeah.
That is all. These two things are required. Then Rolle's theorem says that there exists a point C such that the derivative at C is going to be equals to FB minus FA over B minus A. Okay.
Uh-huh.
So how we are going to just understand this? Just allow me to use the graph for the understanding purpose.
So basically
Okay.
the slope of between the points A
Yes,
and
yes,
B.
you are absolutely right. You are absolutely right there. You are good actually in maths. Okay. Seriously, till now, what I observed, you are good in mathematics without any issue. So just suppose these are the 2 points. This is you may call AFA,
Yeah.
and the other point is going to be BFB. And you need to join them by any curve, which should be differentiable or continuous. Let me just use this kind of curve.
Okay.
Okay. So if you consider them like the points AB and you join them by AB, so you rightly pointed out this right hand side is going to be the slope of line AB.
Yeah.
Okay, so what you need, you just copy this, paste somewhere, try to find the point where the tangents are going to. So where the tangent is going to be parallel to the line AB.
Oh, okay.
So this point corresponding to this point C1, you have a tangent line which is parallel to AB, and corresponding to this point C2. Okay, earlier is not straight, should be yes. Sorry for this.
Mm.
C2. Now it is better. So basically, you are able to find 2 points where the tangent is parallel to the slope AB.
Oh,
Now
okay.
observe that in case if I say that my FA equals FB in this
Mm.
mean value theorem MVT. If I use this particular condition, then the right hand side will be 0. Am I right?
Yeah, so then the other
Which
theorem would also apply?
yes, which is basically which is basically Rolle's theorem. Okay, so
Yeah.
Rolle's theorem is going to be a particular case of mean value theorem.
Mm-hmm.
Am I right?
Yeah.
So there is a question based on the same. Let us try to find out. Just try to have an example like it is given to you example number 3 in the book. Look at the function fx is given to like 5 minus 4 upon x. Find all values of c in the open interval in point 1 to 4 such
Mm-hmm.
that this term exists. Now tell me the function fx is given to you. It is like 5 minus 4 upon x.
Right.
Okay. Can you please tell me the domain of this function?
The domain is that it can't be, it's like anything but 0.
Perfectly okay. Anything but 0. That means to say that x cannot be 0 certainly, and this is not the part of the interval 1 to 4. So the
Yeah.
function is continuous there without any issue.
Right.
If I ask you about the derivative, it is going to be positive 4 over x square without any issue. Again, x cannot be 0, and in the given interval, I need not to worry about 0,
Right.
right? So
Yeah.
that means to say that over the on the given interval, the function is continuous and differentiable. So I can apply the mean value theorem. So therefore, by mean value theorem, there exists a point C belongs to the interval 1 to 4. See, sometimes you may get points beyond the range 1 to 4 satisfying the same property, but you need to answer only those points which lies in the interval. Okay, don't go
Okay.
beyond the interval 1 to 4
Okay.
such that the derivative at C is going to be this is f4 minus f1 divided by 4 minus 1. Derivative at C is going to be 4 over C square without any issue,
Yeah.
right? And
Mm-hmm.
you will be getting how much? F4. If you just plug 4 there, I think 5 minus 4 is going to be 1 for you. If you plug 1 there,
Yeah.
5 minus 4 is
Wait.
it should be
Yeah.
4. It should be 4. My bad.
1, yeah,
If it
4.
is 1, it is going to be 1 there. Divide by 4 minus 1, that is
That's
3
1.
there.
So
Can you
it's 1.
please help me to get the value of C, please? Is it plus minus 2? If I have not made any calculation mistake.
Yeah. Wait, okay, so
Just
12.
look at it.
Yeah, it is. Yeah.
If it is okay, if it is not an issue, so I will discard minus 2, and the reason being minus 2 does not belong to the interval. So the
Right.
answer I'm going to give you is going to be plus 2 only.
Okay.
Agree?
Yeah.
So
So when
can
you're,
you
wait, I have a question.
please?
So when you're writing this full proof, you say by MVT, and then you state that if a point C is this, such that, and then do you have to write out everything in between? I mean, you probably
Yes,
actually do. Yeah, okay.
I
And then you
think
say,
you should, yes.
okay, and then you say C equals, does not, equals plus 2.
Yes.
Okay.
So this is a similar statement. There exists at least one point. I forget at least there. At least one point.
Oh, okay.
Okay, because there can be more than one. So this is the statement I'm going to use for MVT and Rolle's theorem, because I need
Okay.
to tell which theorem I'm going to apply there,
Mm-hmm.
depending upon the situation.
Yeah.
Okay. So uh, there is a question, and this question is based on some application of this MVT. Here you will not be able to see the question like the function is given to you. You need to figure it out. By the way, if you just
Yeah.
try to help me,
Okay.
this is a question based on the velocity and speed. Just suppose ST is representing the distance covered. Just suppose for the moment. Okay.
Yeah.
What S prime T represent? This will represent the velocity,
Yeah. And then S prime
and
prime T is
velocity,
acceleration.
yes, velocity is basically at a particular moment. What is going to be the velocity? That is instantaneous rate
Instantaneous.
of change.
Yeah.
Okay, so and if I'm writing like ST minus SA, oh sorry, the, I'm writing like there is a time period ST2 minus ST1 divided by T2 minus T1. So it is going to be the average speed. Am I
Right.
right? So
Yeah.
basically, it is the rate. It is the in the numerator you can find the distance, denominator, the time taken. It is the average speed. So the question is, if you apply the mean value theorem, at what point the average speed is going to be equal to the velocity? You got it?
Okay. Yeah.
Okay. So there is a question based on the same. Two stationary petrol cars equipped with radar are 5 miles apart on a highway. As shown in the figure, let me just show you the figure also. I was
Okay.
not expecting to have the figure. Give me a second.
Okay.
Okay, just look at the figure. I hope it is
Mm-hmm.
visible to you clearly.
Yeah.
A truck passes the first petrol car. Its speed is logged at 55. So moving this direction, at this time the speed was 55
Yeah.
miles per hour. So mph, maybe mph is a short form.
Yeah.
4 minutes later, the truck passes through the second car. Its speed is clocked at 50. So at this point, the speed is going to 50 miles per hour, mph.
Yeah.
Prove that the truck must have exceeded the limit 55 at some time during the 4 minutes. That means the maximum speed on this, you can say, road is going to be 55. So
Yeah.
the truck must have crossed this limit. This is the statement we need to prove this. 55 miles per
Okay.
hour. Any
Yeah.
doubt there?
No.
So for the purpose of solving this question, I can assume that at time t equals to 0, the truck was near this the first car, and at time t equals 4 there. These are given in minutes. You need to convert that time in hours. So what
Yeah.
is T1 there? T1 is going to be 0 hours, and T2 is going to be 4 minutes.
Right.
And 4 minutes is going to be how much?
1/15. Oh
4
no.
by 60 hours. Am I
Yeah.
right?
Yeah.
That is 1 by 15. So please try to help me. What is going to be the average speed? Average speed.
Yeah.
Average speed is
So
going to be the distance covered divided by the time spent. Am I right?
right.
So it is going to be the distance, like the notation I used earlier, divide by how much? It is T2
Divided
minus
by
T1.
1/50. Yeah.
Perfectly okay. You 1/15. So I know the distance going to 5 miles. It is given to me 5 miles. What is T2? It is 1/15 there. So
1/15.
it is 75.
Right.
Okay. Now, assuming that the function is differentiable, okay, and we can apply the mean value theorem. So using mean value theorem, I'm assuming that this S is going to be differentiable. If it is not
Okay.
differentiable, I cannot apply the mean value theorem. Using mean
Yeah.
value theorem, I can say that the velocity, which is nothing but the derivative, should be equals to at some point, say C, should be equals to this S 1 upon 15 minus S0 over and this 1 over 15. Am I right?
Yeah.
Which is 75. And that
Right.
means to say that there is a point because at some point the velocity should be 75. This is what the mean value theorem says.
Yeah.
Okay, that means to say that there is at least one point. That means there exists at least one t where the speed is 75. Is 75, which is more than 55. So the truck exceeded the limits. Do you agree?
Right. Yes.
Okay, so the basic assumption here is it is differentiable. Okay, so it's an easy task for you. I hope it's not a big task. Yes. So one more thing I wish to write down. So you are going to use this type of statement. It is the mean value theorem, but the way of writing is different. It is the mean value theorem, and you can easily see the derivative at C was earlier. It was FB minus FA over B minus A. So if I ask you to tell me FB, you just multiply them and simplify. This is what you will get. Okay, so these kind of expressions are going to be important in some cases. Like if I ask you, can you please help me in finding the square root of 25 without using calculator? I'm just giving you one example there. Okay, so how can I find this type of statement? So 25 I know, actually 25 I know. I'm asking you about 26 for the moment. Okay, this is you, this you know, like 5 there. I need to ask you what is going to be the square root of 26. So what you tell me that consider there is a function like this, square root of x. Consider the value of value like a, a is 25, so that you know the value of the function. B is 26. You need to help me with the derivative there.
Okay.
So 26 there. So in similar kind of approximation, we are going to use this. So if you allow me for the moment, this is going to be F26 is going to be F25 plus B minus A. B minus A is going to be how much?
26 minus 1.
1. It is going to be 1 there. And this is going to be derivative at C. C is going to be in between them. 25 to 26. Give me. So what is the derivative of this function? It is going to be 1 over square root 2 square root of C lies between 25. So this is 5 plus. I do not have the value of square root of C basically. So I cannot give you the exact answer. But approximately the answer is going to be 2 square root of 25. See, I'm just going to plug. I cannot find the exact value. It is just an approximated value. So it is 5 plus 1 over 2 into 5 It is going to be
Oh,
5 plus 1 over 10, that is 5.1. So approximately, if you ask me what is the answer, it is approximately. Let me tell you, it is not the exact.
yeah.
Okay, but yes, you have an idea. So sometimes these kind of functions are going to be important for you. And later on,
Okay.
you will see that there are some theorems like Taylor's polynomial, Taylor series, you will see. So those are the expression where we use the derivative to find a series expansion of some of the functions. Okay, later on when you will be in graduation, you will see to it.
Okay.
Okay, so this is the theory part and it is done for you. So let me just ask you some question based on the same. It is given to you in the book. In the book, basically, yes. Uh, with the graph, I'm using them.
Mm-hmm.
There are two functions given to you. Function is 1 minus mod x minus 1. Can you please help me if the function is differentiable?
The function is not differentiable. Oh, and then the second one is also not it's not continuous.
See, the problem you told me correctly. If I ask you if it is differentiable, because there is sharp change at 1, so you should tell me like it is not differentiable at 1.
Oh, okay.
Okay, you are absolutely right. It is not differentiable, but if you tell me that it is not differentiable at 1, it is a better expression. So that
Okay.
means to say that in the interval where it includes 1, I cannot apply the Rolle's theorem. Okay,
Yeah.
so I am not able to apply the Rolle's theorem. It is not applicable there.
Yeah.
What about the second function? If you just look at, and the interval is going to be from 0 to pi. Consider the interval 0 to pi for the
From
moment.
0 to pi, it's continuous and differentiable.
Okay, there is an issue there because if you look, there is a vertical tangent at both 0 and pi.
Oh, okay, yeah,
Okay,
right.
so that means the function is not continuous over the interval 0 to pi. So if you consider this function over the interval 0 to pi, it is
Not
not
continuous.
continuous because you have a infinite tangent. So in this case also, I'm not able to apply the Rolle's theorem. Or otherwise, if you need to apply the Rolle's theorem, just take a horizontal line. I hope it is horizontal. Just
Yeah.
try to move it around. Try to find out a point where the tangent is going to be 0. And
Okay.
I hope there is no such point. Okay,
Yeah.
so you can just approximate like this also. And it out?
Nope.
No, perfectly okay. So these are the things you can identify easily. Please help me with the question number 4. You need to check the applicability of the Rolle's theorem.
Yeah. Um,
The interval is
so
given to you.
it would be continuous, right?
For the continuity purpose, you need to check the domain there. Okay, because if there
Yeah.
is nothing in the denominator, we need not to worry about the denominator. Only
Right.
look at the domain fit basically. So for the domain, this part x2 by 3 power 3 must be positive because the exponent is odd there. Okay, if it is
Yeah.
even for whatever the whatever 2 minus x power 2 by 3, it is going to be positive. But
Right.
because it is odd, you should tell me that this can only be true whenever it is. I can use the word 0 also
Yeah.
like this. And it out.
Nope.
And that means to say that this x power 2 by 3 is going to be less than equals to 2.
Okay, yeah.
Agree?
Mm-hmm.
Perfectly okay. So now that means x is less than equals to how much? 2 exponent 2 by 3. Can I write like 3 by 2 there?
Uh, ye-
Or you please allow me to use x square is less than 2 power 3. Is it so? Just
yeah.
using x 2 by 3, exponent 3 on both sides.
Mm-hmm.
because this will not. Now x square is less than, that means going to be mod x is going to be less than equals to how much? 2 power 3 by 2.
Yeah.
So 2 power 3 by 2, if you see, that means x can belongs to negative 2 power 3 by 2, positive 2 power 3 by 2, and the interval minus 1 to 1 is contained in this interval. Do you agree?
Right. Yeah.
So that means there is no issue in the continuity there. So if you ask me
Yeah.
about continuity, no issues.
Mm-hmm.
Okay, it is done. Please help me, try to help me with the derivative there.
Okay.
Derivative of the function, and please try to check if there is an
It would be
issue
chain
in the
rule,
interval.
right?
Yes, certainly it will be chain rule.
Yeah.
So should I find the derivative, or you know the derivative, how to find out?
I know how to find it.
Okay, then find it and tell me the derivative, please.
Yeah, I just need to get like a good marker that, or actually I'll just use this paper. Sorry, I need to find like, because my marker isn't working right now, so.
No issue, no issue. You can use your pen and paper. You can dictate me or you can send me, whatever you wish.
Okay, I'll just dictate.
Perfect.
Okay, so because it's chain rule, I normally rewrite it in terms of parentheses. So 2 minus
So first of
x.
all, let me just rewrite the statement. It
Yeah.
should be like 2 minus x power 2 by 3, exponent 3 by 2. Am I right?
Yeah.
And now the power rule is applicable there. I can write 3 by 2, 2 minus x power 2 by 3, exponent 1 by 2, that is square root, multiply
Yeah.
by the derivative. This time is going to be, the derivative 2 is 0, minus the, what is the derivative x power 2 by 3?
The derivative x, it would be 2/3 x 1/3, negative 1/3, yeah.
Okay, so I wish to have positive exponent. So you please help me, like 3 by 2 in the numerator, I will be having like 2 minus x power 2 by 3. 2 by 3 should cancel out this 3 by 2. So let me just erase them, only negative sign. In the denominator, I'm expecting that I should have x power 1 by 3. Do you agree?
Yeah.
Now tell me,
Wait, what happened to the 2/3?
2/3. I think this 2/3 got cancelled with this 3 by 2.
Oh, okay, yeah.
Okay. So now please try to help me. What should I say about the existence of the derivative in the open interval minus 1 to 1?
Wait, you have the derivative, and then you, we know, we make sure it's like not, we find the point where it's like,
The denominator
like,
is 0.
yeah,
It
because it
doesn't
doesn't,
exist at
it
x
wouldn't
equals to 0.
exist.
And 0 belongs to the interval minus 1 to 1. Open interval, sorry, open interval minus 1 to 1.
Yeah, it's
So
in that,
that means the function is not differentiable at the point minus 1 to 1.
yeah,
And that is all. So that means Rolle's theorem is not applicable.
right,
Means your Rolle's theorem is not applicable.
yeah.
Okay, I have not an issue there. It's an easy
Mhm.
task for you. So uh, we have not checked the third point actually, but we need not to go to the third point because the second, the derivative doesn't exist. Why to go for the third one?
Right.
Okay, it is meaningless for you. Okay, please try to help me with some more question based on the same. If you
Oh, okay.
So the question you need to help me is 21 and 23. I wish. These are the question. Determine whether the Rolle's theorem can be applicable. You got it?
Yeah.
Okay, so you have got two questions. Can you please try to help me with 21 first? Start with 121. Try to dictate me and the applicability of the Rolle's theorem.
Okay.
And once the Rolle's theorem is applicable, you should be able to tell me at what point C the derivative is going to be 0. Right?
Okay.
After this application, you need to tell me the point also, please.
Right. So basically this is continuous
This is continuous without any issue, and the reason being
because it's like a sine squared function. So,
perfectly okay. Let me just add one more thing here because there are two terms. One is the linear term x, one is sine there.
yeah,
X is continuous, it's a polynomial. Sine x is continuous everywhere on the real line. And if
yeah,
you add, subtract, multiply continuous function, it is also going to be continuous. So I don't have the issue in continuity over the interval 0 to pi there. So you are
yeah,
right, continuous on 0 to pi. I don't have an issue there. 0 to
yeah.
pi by 6, sorry. Second statement.
It's the one where we check if it's differentiable or
Yes,
yeah,
differentiability. Just help me with finding the derivative. Is it 6 upon pi minus, I should write like 8 sin x cos x, right?
yeah,
Again, there is no issue. It's a simple, straightforward question. Sin x is exists everywhere, cos x exists everywhere. So that means it exists over the interval 0 to pi by 6 in particular. There is no
yeah,
issue in the existence of the derivative.
yeah.
Third thing you need to check for me, like what is f0? Is it 0?
Um, 0. Yes.
And what is f pi by 6? Please calculate.
Okay. F. Okay, wait. So 6x over pi. I'm trying to do this in my head because I can't find a pencil. Hear me? Is it 6? Wait,
Take your
6?
time. I need the
Yeah.
value, please. It
I'm gonna get a pencil. Root
is
3
the
over.
first term is going to be 1 there. 4
Oh,
times sine pi by 6 is going to be 1 by 2. So it is 1 by 2 square. It is going to be 0 for you.
oh, okay. Yeah.
So now all the three conditions are satisfied. So therefore, by Rolle's theorem, there exists at least one point, the similar statement you need to rewrite every time. Okay,
Okay,
so
yeah.
where the derivative is going to be 0. So you have the derivative in hand, like 6 upon pi minus 8 your sin x cos x is going to be 0. Can you please help me in solving this statement? It is 6 upon pi minus 8 sin x cos x. I'm just giving
Uh-huh.
you a hint. 6 upon pi is
Oh,
okay. I can rewrite
point eight
like
equals
2
0.
sin x cos x is going to be sine of 2x.
Yeah.
Okay, now make use of this relation. Try to help me. What should be the value of x?
Um, it could be 2 pi or 0.
You know,
Wait, oh, sorry.
it is not the way
Pi
of
over
solving the
2.
question. Give
Wait,
me a second, please. So
pi over
let me
4.
just. I'm writing from this step or from this step, maybe on the left hand side. If you can see, for me, like sine 2x multiplied by 4 is going to be 6 upon pi. And if you allow me, I can divide by 4 also. Sine 2x is going to be how much? Is it going to be 3 by 2 pi? Am I right?
Yeah.
Okay. So in this case, are we allowed to use calculator there?
No.
Uh, okay. If the answer is no there, please help me. Pi is going to be 3.14 approximately. Am I right? Approximately
Right.
3.14. And 3 by 2 is going to 1.5. So 1.5 divided by 3.14. Is it going to be less than 1 by 2?
Um, y- n-
Yes. 1.5
yes.
twice is 3 there. So no issues are there. So it is within the range. So in order to get the value of 2x, I should be able to use sine inverse 3 upon 2 pi. Agree?
Um, oh, yeah. Yeah, I see it. Yeah.
Okay. And what should be the values? Let me just tell you up to this point, the sine inverse. Sine is an increasing function. You know, sine is an increasing function over the
Yeah.
interval 0 to pi by 2 there. So this is going to be pi by 2. I need to talk about pi by 6 there. At pi by 6, it is 1 by 2. So the graph goes like this. Okay, the graph goes like this. This point is going to be at half the value, it is 1/2. Even if it is not visible, consider like this. So that means
Okay.
sine inverse is going to give you some value in the interval between 0 to pi by 6. This belongs to the interval 0 to pi by 6 there without any issue. So what should be the value of x? It is 1/2
Of
sine
sine
inverse
inverse
3
of 3
upon 2
over
pi, which
yeah.
is still in the interval 0 to pi by 6. Do you
Yeah,
agree?
because it doesn't change it, yeah.
Even if you divide, so you get a point like this. And if the calculator, if we are allowed to use the calculator, we can do anything,
Mm-hmm.
right?
Yeah.
Perfectly okay. So now in the next question, please try to help me. The applicability of Rolle's theorem for the question 10 x equals 0 to pi, 10x in the interval 0 to pi, please. Please try to discuss this. Talk about the continuity, differentiability, whatever you know about it.
Um, yeah, so tan is,
You want me to draw the graph?
yeah, sure.
Okay. So, okay, so there are going to be vertical lines. This is the line I'm going to use for pi by 2. And this is the line for pi by 2 plus pi is going to be 3 pi by 2. And on the left hand side, I have vertical line negative pi by 2. So the graph goes like this. It is going to be
Right, okay, yeah.
something like that. And you have a similar type of graph. And the interval we are concerned about is from 0 to pi. This point is going to be pi for you.
Yeah,
So in
so
this
it is
interval, you
different.
need to focus.
It's not continuous.
It is not continuous. You got the answer. So the Rolle's theorem cannot be applied there. No doubts.
Yeah.
It's an easy task for you. Okay, so let us do one question based on the application part, because in your case, teacher will give you good applications. Vertical portion. The height of a ball t seconds after it is thrown upward from a height 32 feet and with an initial velocity 48 feet per second, it is governed by this relation given to you. Okay.
Yeah.
Verify that f1 is equals to f2. That means the height at time 1 and f2 is going to be the same. You get the
Yeah.
meaning of this statement?
Wait, so that means in
That
1
means
second and then in 2 seconds, it'll
yes.
be the same height. It's like a parabola, I'm pretty
Yes, I'm at time t equals to 0. At t equals to 1, just suppose this is going to be the height. Let me just draw the graph of the parabola. This is
Yeah.
the normal curve of a board. At t equals to 1, consider you are here.
Mm-hmm.
1, this is 2 there. At 1, 2, you have the same height. So this is what the observation is. So you need to verify the first term. And additionally, you can help me in finding. This is the right hand side is a polynomial, and polynomial is continuous differentiable everywhere. Am I right?
Yep. Mm-hmm.
In particular, the closed interval 1 to 2 also.
Right.
And 1 to 2, it is like f1 is f2. So all the conditions of Rolle's theorem are satisfied. Am I right?
Mm-hmm.
So that means to say that there must be a point where the derivative is 0. Well, ft represents the height. The ft represents the height basically. And what is f prime t? It is going to be the velocity at a particular moment.
Yeah.
Okay, ft is
Instantaneous
basically the
velocity.
distance covered because it is they are throwing it upward.
Yeah.
So it is not horizontal now. I hope it is horizontal. So you need to help me that there is a point C where the tangent is going to be 0, and that means that point is going to have the maximum height. Can you please do the B part?
Yeah. So it starts with 48 feet per second. So at t equals 0, the f prime
We need to
of
not to discuss what may be t
oh
equals 0. Only concern about
oh
1 to 2. So you need to tell me that f prime uh, t is going to be 0 for you,
negative. Oh yeah.
and I need to search the solution in the interval 1 to 2 only.
Oh okay.
Okay, simplify this
So
term.
basically we'd have to set it to 0. So I differentiate the whole thing for yeah, so negative 32t plus 48, and that's it.
And what it should be? 48 divided by 32 is going to be how much? 16 threes
Or
are and twos are. That is 1.5.
yeah.
So at 1.5 seconds, is it seconds? Yes, 1.5 seconds. The velocity is going to be 0, because if the velocity is not going to be 0, it will continue to move upward.
Mhm.
At this particular moment, the velocity is 0, then it will start going down.
Right.
Got it? Okay. So these are some simple tasks for you.
Wait, in B, I have a question. So it's asking what must be the velocity at some time in the interval. Are we just supposed to assume that it's where the tangent is 0,
Uh,
or like
what must be
or
the
it,
velocity at some point? Yes. So basically, at Rolle's theorem says that there is one point where the derivative is 0. Derivative is representing the velocity. So there is one point where the derivative must be 0. So what must be
okay.
the velocity at some point? It should be 0. This is what the
Okay, yeah.
question is. Because we have the surety about 0 only. We don't have surety about anything else.
Right.
Right?
Hmm.
Okay, so let us go to the next question if you wish to help me. There are two questions given to you, and you need to tell me the applicability of mean value theorem, MVT.
Okay. But it doesn't apply to both.
Hmm.
Oh, it already
Then
says that. Oh, I need to explain why. Okay. So for the first one, it's not continuous, and for the second one, it's not differentiable at
perfectly okay.
2.
Uh, can you please help me? It is not continuous. What type of discontinuity is there?
Um, the one where a point is not defined in the continuous function and it's defined somewhere else at a
And
different
this
y.
is there is a name of this particular discontinuity. We call it removable discontinuity.
Oh, okay.
Removable in the sense that if you allow me to redefine the function like it has the value at 2 equal to this whole, that means whatever the height is here. So then this discontinuity will be removed. Okay, so this type of discontinuity is called removable discontinuity.
Okay.
Another type of discontinuity is like you have function and then after it is starting from this way. So where there is a jump, we call it jump discontinuity.
Okay.
Okay, because there is a gap. You got it? There is
Yeah.
a gap. So I'm using the wording removable discontinuity for the moment. You are right there. There is a discontinuity.
Yeah, and then the next
So
one is not differentiable because it has a cusp at
first
x
time.
equals 2.
You are absolutely right there. Okay, so I don't have any better questions to discuss with you. I can share the book with you. You need to just go through the book and try to help me if you just try to just do some problems from there.
Okay.
Okay, let
Can
me
you send
just,
it to my number?
yes, I can send you, and there are some easy stuff for the moment if you can stay. Look at these
Okay.
inequalities. Mean value theorem is extensively used to prove some of the basic inequalities like this, what I'm showing you right now. It is from question number 83 and 84. I skipped most of the question because we have limited time. Look at the question there. If you consider for any of the function, if you consider the function like first for it is cos x. What is the derivative of cos x?
The
It is sin
derivative
x.
of cosine x is negative sin, oh wait, just sine x.
If you consider the interval AB, there is no issue in the continuity over the AB, and there is no issue in the continuity in the existence over the interval open AB.
Yeah.
So by MVT, this FB minus FA over b minus a should be equals to the derivative at some point c. What is c? C lies between a and b. Do you agree?
Yeah.
This is the statement actually you have. Let me just put the more there. So what is the right hand side? Right hand side is nothing but tan c. Sorry, sin c. Sorry for this. Now sine is a function with the range of sine is going to be from -1 to 1. It is always less than equals to 1 there. Do you agree?
Mm-hmm.
So that means to say that my fb minus fa upon b minus a in mod, it is less than equals to 1. So it is fb minus fa. It is always less than equals to how much? B minus a. Am I right?
Right.
Just plug the values.
Wait a minute. Wait, I have a question.
Please.
How would sine of c be less than 1?
Because the maximum value of sine, the range of sine is going to be -1 to 1.
Oh, right. Okay, never mind. I got it.
Okay. In mod cases, in whenever you are using mod, I can rewrite like less than equals to 1 always.
Yeah.
No issues?
Yeah.
Okay, now the task is simple for you. What is fb minus fa? You see, I can rewrite like fa minus fb because I need to prove like this. In mod,
Yeah.
there is no issue. You can write the value fa like cos A, fb like cos b. So when you plug the value, this is the inequality you will get. Am
Yeah.
I right?
Mm-hmm.
And similarly, if you use the function sin x, you can prove a similar inequality.
Yeah.
No doubts?
That makes sense. Yeah, that makes sense.
Okay.